Hi guys, welcome back to another video. Here we're going to be looking at sketching different types of functions. So, as you can see, I've written down different types of functions which appear in the IB HO math exam. There are a myriad of functions and, well, you have to be able to sketch all of them. I know it sounds like you have to go ahead and memorize a lot of graph shapes and all, which isn't easy for many people, but that's not actually the case. If you understand how the graph is derived from the equation, you could actually go ahead and you could actually remember the whole concept of sketching functions much better, and it's more of a skill rather than actual memorization. So let's look at linear functions. So this is obviously the most basic one. Linear functions are basically a straight line, and usually take these two graphs where this is the function y is equal to f of x, y is the range, x is the domain, m is the gradient. Gradient is basically a measure of the slope of a straight line. Here you got to remember that when m is positive, the graph is something like this, and when m is negative, the graph is something like this. So that is the one thing you have to remember. C is obviously the point at which it intercepts with the y-axis. So how do you sketch quadratic functions? Well, look at the first term. If a is greater than 0, then it is a minimum function, which means the shape of the graph is a u. And if a is less than 0, well, it is a maximum function, and the shape of the graph is something like this, meaning it has a maximum point, and this has a minimum point. So all quadratic functions have this parabolic shape, so you just need to figure out which way it is oriented. The next thing we need to know is c. C is the y-intercept. Just remember, for all polynomial functions, the constant which you find is always the intercept with the y-axis. The third step is to calculate the minimum or the maximum point. To do this, many of us use calculus, but there's actually a much simpler way, and that is to use this formula, minus b over 2a, where these terms are taken from this equation here. When you do this, you basically get the x-coordinate, where the line of symmetry in a quadratic function, this would be the line of symmetry, or if it's the other way around, this would be the line of symmetry. And then you can substitute this x-coordinate into the main equation, and you would get the coordinates for the max or min. So after you get the coordinates of the maximum or the minimum point, which is like this shape here, well, you already know that a quadratic function will always have a parabolic shape. It will either be this or this. Since we know that, and since we know this point, and since we also know the y-intercept, because c is the y-intercept, now all we need to know is the two x-intercepts. And to find the two x-intercepts, we just equate y is equal to 0, because we need to find the point where the curve intersects the line y is equal to 0. Once we equate y is equal to 0, we can solve the quadratic equation, and this is quite basic. I think most of us have already learned this in our lower classes. And once we get the two values of x is equal to z and x is equal to q, well, z and q will be your x-intercepts. Now you can easily sketch the graph. There's actually another way to do this, and that is by completing the square. And it's a very quick way to do it, but if you guys don't know how to complete the square, I think you guys should check out another tutorial on that, because it's quite a useful technique and you need to know how to do that. When you complete the square, you get an equation in the form y is equal to a into x minus h square plus k. So how do we interpret this? So basically, a is still the same a, and we can use that to find this, and then your negative h and k are the coordinates of the turning point. So this would be somewhat of a faster method, I guess. Depends on how confident and how fluent you are with the completing the square method. And you still have to solve this equation by equating y is equal to 0 to find the two x-intercepts. Let's move on to the cubic function, where whenever you have a constant which is not a coefficient of any x term, well, you always know that's the y-intercept, because, well, when you substitute x is equal to 0, everything else will become 0 except this term. So how do we go about figuring this out? So just like quadratic functions, the a term is important to figure out the shape of the cubic function. So there are two rules. If a is greater than 0, the shape goes up, then down. If a is less than 0, then it goes down, then up. These are the two possible shapes for cubic functions. Again, we need to solve the cubic function for the x-intercept by equating y is equal to 0. And if you guys don't know how to solve cubic functions, well, you guys can leave a comment below and I'll create a video, but it's quite simple. Basically, you assume one of the possible factors, for example, x plus 1 or x minus 1, it's most commonly one of these two, and then you can go ahead and divide the whole cubic function by that factor and hope that the possible factor, so that you can simplify the cubic function into a quadratic function and then solve it from there on. If you guys really want a more in-depth tutorial on that with an example, leave a comment below and I'll definitely make one. That's basically it for cubic functions. They're quite simple. Let's look at higher polynomials. So this method only works when they give it in a factorized form like this. If they don't give it in such a form, suppose it's x power 7 something, suppose the equation involves the highest degree as x power 7, then well, if you can factorize it to something like this, then yeah, that's the only way you're going to be able to sketch that graph, unless you're using a GDC, of course. So how do we go about doing this? So basically, again, there are just 3 different rules that you have to remember. So let's take these 3 different factors, separate them. So every time we have something like, when we equate y is equal to 0 to find the 3 x-intercepts, over here at x is equal to a, so this is x minus a is equal to 0 is a linear function. Whenever we have this linear factor and the degree of the whole factor is just 1, you need to know that the function will intercept with the x-axis at a. At that point, the graph will be linear. If at x is equal to b, you can see that this is quadratic as the degree of that factor is 2. Well, in those situations, the graph will form a parabola. So it'll either go from a maximum point or a minimum point. So how to figure out which shape it is out of the 2 possibilities in these cases, I'll discuss a bit later. At x is equal to c, this factor is cubic, that is the degree is 3. So you got to remember that. So if you guys can recognize this is nothing but a point of inflection. So you got to remember, when it's a linear factor, that is the degree of the factor is 1, it'll just intersect that line and be linear at that point. And if the factor is quadratic, that is the degree is 2, well, it'll be a parabola. It'll either be a maximum or a minimum point. And if the degree of the factor is 3, it'll be a point of inflection. Well, the shape will be like this or like that. Now, how do we figure out which shape? Like at each point, there are 2 possible shapes it can take. How do we figure out which of those shapes are taken by our function? So what you do is, after figuring out all this, check the y-intercept. So how do you do that? Well, x is equal to 0 and you'll get your y-intercept. Once you have your y-intercept, well, it's a matter of trial and error actually. So, it might sound like, oh my god, so trial and error, so there's a high chance you'll get it wrong. Actually no, it's quite simple, because if the y-intercept is here and you know x is equal to a, if a is a positive term, a is somewhere here, well, you know the graph can't be like this, it has to be like this. So you've already figured out one shape. Or if b was here, well, you know the graph cannot be like that. It needs to touch both these points, and therefore you figured out the shape. And likewise, if this was C, well, the graph has to be something like that. The graph has to be something like that. So basically it's trial and error, but when you guys try out questions, it's quite self-explanatory. If you guys want me to make a video where I go through examples using these rules, well, drop a comment below and I'll definitely go through that. Next up, let's look at exponential functions. Exponential functions have 2 rules that you have to know. If this a is greater than 0, then the function will have this shape, and if a is less than 0, the function will have this shape. If a is a positive term, well, it's becoming more positive exponentially, and if a is a negative term, well, it's becoming more negative exponentially. So that's how I like to remember it. So many of you will be like, hold up, what about e power x? So if you guys know, e is called the Napoleon constant, and it's something like or the exponential constant 2 point something. So you can see that E is basically positive. So E follows this rule over here. Yeah, what about e power negative x? Well, so basically over here you're going to be using transformations, and I'll be covering this in a separate video. E power negative x or negative e power x, stuff like that. So logarithmic functions, in low classes you probably learned that to sketch an inverse of a function, you basically sketch the graph of the original function, and then let me sketch the graph, and then you draw the line y is equal to x, and then you just reflect the function over the line, b log x to the base a. So basically one simple way to solve this is to convert the logarithmic function to an exponential function. So that would be, now I would just, so basically we're finding the inverse of this function, and to do that we have to swap y and x and then make y the subject again. So that would be, well, you can use the same rules as a power x over here to sketch the function, but here we're assuming that b is equal to 1, but b does not necessarily have to equal 1. I'll be covering like transformations of the original function in a separate video, so I'll link that below, and it probably has appeared in the cards up till now, but yeah, go ahead and check that out to fully understand how to sketch different versions of the functions. In this video I'm basically covering the basic forms. This is one way to do it, but there is another way, and that is to again remember a set of rules, so these rules are derived from the rules for exponential functions. So if a is greater than 0, the shape is something like that, and if a is less than 0, the shape goes something like that. For both exponential and logarithmic functions, the position of where the graph would be is based on the y-intercept. Sometimes the y-axis could be an asymptote, but based on that, then you can also calculate the x-intercept and the y-intercept if it has those. So you can calculate the x-intercept and the y-intercept and accordingly place the graphs. This is just the general shape. So if a is less than 0, well, you get, so based on that we have this shape, and it's basically the opposite of exponential function. When a is greater than 0, well, you get this shape, and when you reflect that shape over y is equal to x as we've done here, well, you get this shape. Likewise, if you take this graph and reflect that over y is equal to x, well, you would get this shape, and that's how you derive the rules. So how b matters will be discussed in the transformation video.